one and all. For the subject cryptography and network security. The topic being discussed today is email security. The part 1 of these topics in today's video will be focusing on. Part 1 comprises of email security, introduction to email security, pretty good privacy, MIME, which stands for secure multi-purpose internet mail extensions. So email is the common form of communication. All of us use Gmail or some other sort of mail. Email may contain confidential information like passwords, documents, personal data. Emails are vulnerable to attacks like eavesdropping, spoofing, phishing, tampering. Phishing as in fake emails to steal login password. Spoofing as in faking sender address to look like a trusted one. Replay attacks, resending intercepted emails. Tampering, modifying email content in transit. Malware attachments, email attachments contain viruses or spyware. So these are few of the threats when we are sending emails. We may face phishing or spoofing or replay attacks or tampering or malware attachments. What are the objectives of email security? We want to achieve confidentiality, authentication, integrity, non-repudiation. What confidentiality indicates? Only sender and receiver of the email can read the message. That is confidentiality. Authentication indicates you have to prove the identity. Whosoever is the sender, he has to prove the identity. Integrity indicates ensure message is not altered in transit. Non-repudiation indicate sender cannot deny sending the message. So these are the objectives of email security: confidentiality, authentication, integrity, non-repudiation. What are the methods used for email security? One is through encryption. For example, we may use PGP, pretty good privacy, or MIME. We may use digital signatures, public key infrastructures, secure hashing. So this is the typical ecosystem for email security. There is a sender who will be sending the email. There is an email server. So encrypt and sign will happen. Over the internet, the email message will travel. At the receiver, there will be a email server, decrypt plus verified, receiver will be receiving. This is what is the typical flow. So in email security, the first part begins at the sender, because sender will be sending the message. So what the sender will be doing, he will be signing the email using a private key so that authenticity is ensured. Then after signing, he will be encrypting the message using the receiver's public key to ensure confidentiality. So what is happening here? The message is both encrypted as well as signed. What is the purpose of encryption? Only the receiver should read the message. What is the purpose of signing? The verification by the receiver happens that he is the correct sender. Now step 2. Once sign and encryption happens, the email which is encrypted and signed travels over the internet. Even if it is intercepted, the message is unreadable to outsider because it is encrypted. At the receiver, what will be happening? The receiver using his private key to decrypt the email and access the original content. Then he uses the sender's public key to verify the signature, checking whether the message was tampered with or came from the actual sender. What is the final result? Privacy is preserved. Only the intended recipient can read the email. Authentication and integrity are ensured. The recipient is confident the email came from the actual sender and wasn't modified in transit. Now coming to PGP, email security offered through PGP. PGP stands for Pretty Good Privacy. It's a protocol basically. So what is written here about PGP, Pretty Good Privacy? It's an email security program. It achieves confidentiality, authentication and integrity for electronic communications. Okay, so you'll be encrypting the emails, you'll be using digital signature verifications, and you'll be encrypting the files. Now, what are the key features of Pretty Good Privacy? Hybrid encryption. So it may use symmetric encryption such as AES for fast message encryption. It may use asymmetric encryption like RSA to encrypt the symmetric message. Digital signatures. It ensures message authenticity. The sender's private key is used to sign the message. The recipient verifies it using the sender's public key. Compression. Reduces message size before encryption. It may use algorithms like zip. Email compatibility. It will be converting binary data into ASCII text using Radix 64 for email transmission. So these are few of the key features of PGP, which include hybrid encryption, digital signature, compression, email compatibility. How PGP works: at the sender side, the message is created, it is compressed, a random symmetric key is generated, the message is encrypted with that symmetric key, the encrypted symmetric key with recipient's public key, sign with sender's private key, then send. So this is what happens at the sender side. What happens at the receiver side? Use private key to decrypt symmetric key, decrypt message, verify signature using sender's public key. So this is what happens in the encryption process. Raw file using public key is encrypted with, and that encrypted file, so secure lock, then message travels over email or FTP. At the decryption process, encrypted file is decrypted using the private key and the raw file is again generated. What happens in the encryption process will repeat. Okay, there is a raw file. Okay, and that is the raw file, means the message being sent. Then that raw file is encrypted with the public key. Whose public key? Recipient public key. So what will happen? The recipient's matching private key can only decrypt it. So once the file is encrypted, the file is converted into an unreadable format for security. There is a lock symbol which indicates that it is securely locked, that it is encrypted. Now the encrypted file is sent securely over the internet via email or FTP. This is what happens at the encryption. At the decryption process at the receiver side, what will happen? The encrypted file is received over email or FTP. The file is still locked, encrypted, and cannot be read directly. So the receiver uses his private key to decrypt the file. This will unlock the original contents. Decrypted file is now in its original readable form, same as what the sender had sent. What are the advantages of Pretty Good Privacy? Strong security even over insecure network. Widely adopted and proven system. No centralized key management required. It uses a web of trust. Example use cases are secure email transmission, file encryption, data authentication. The next security protocol we can say is MIME, which stands for Secure Multi-Purpose Internet Mail Extensions. So it provides confidentiality, authentication, message integrity and non-repudiation. It uses encryption and digital signatures. So we have a combination here. We start with PGP, Pretty Good Privacy, then we achieve MIME, that is Secure Multi-Purpose Internet Mail Extension. So what are the key features of MIME? It ensures that the message is encrypted and can only be read by the recipient. It uses receiver's public key to encrypt. Digital signatures are used, so it will help in confirming the sender's identity and ensure that message was not altered. So this is created using the sender's private key. Message integrity. If the message is tampered with during transit, the signature check will fail. Authentication. The recipient can verify that the email was actually sent by the claim sender. So this is how encryption and decryption works. Sender is there, plain text email is ready, it is encrypted, the plain text email travels at the recipient. So what happens at the sender side? You will be composing a mail, you will be generating a hash, that is message digest, you will be encrypting the digest using sender's private key, you will be encrypting message using receiver's public key, then you will be sending encrypted message plus signature. At the receiver side, what will be happening? You will be decrypting the email using private key, decrypt signature using sender's public key, validate the hash and verify signature. If everything matches, message is authenticated and unmodified. These are the benefits of MIME: confidentiality, authentication, integrity. So that was the agenda today.